Hello, my name is Yeji Song, and I'm from the MyPa Lab. Today, I will present our paper, Protagonist Diversification with Structure Agnostic Video Editing, or SAVE for short. Our paper focuses on the protagonist diversification in the video. Given a source video, the goal is to edit the protagonist while preserving the motion. The existing methods tend to struggle with this task, especially when the target protagonist has a largely different body structures. I will begin by exploring the limitations of the existing approaches and then introduce our method, which effectively addresses these issues and demonstrate the potential for more diverse and extensive video editing. The most common approaches to video editing is inflating pre-trained text-to-image models to text-to-video models. Additional temporal attention layers calculate the attention scores for each latent pixels across frames, like this equation. The K is the pixel location and I is the frame index. Information at kth pixels of each frame is exchanged, but information from different locations cannot be effectively blended. Therefore, we pin down two problems when entirely relying on the temporal attentions to learn the motion. First, the spatial aspects of the motion cannot be fully explored during training. Also, the protagonist's appearance and motion are rendered with a time lag at inference, where the former is processed in the cross attention, while the later processed in the following temporal attention. Therefore, we turn our attention to motion-related words in the text prompt. Can they spatially inject motion information through cross attention? However, as shown in the figure below, motion-related words often highlight specific parts of the protagonist unrelated to the motion. It is because the word roaring usually indicates the appearance of opening the mouth, while in the video, motion proceeds in the stream of time. A roaring video also includes frames where the mouth is closed, such as first, second, and last frames. Therefore, our goal is to revitalize a motion-related word by reducing these location biases. To this end, we defined the new motion word as mode and expanded its texture embedding space by adding a temporal axis to represent the overall motion throughout the time sequences. This VB is a learnable parameter representing the common aspect of the motion across frames, and it is concatenated this gamma I, which is the positioner encoded frame indices, and they are concatenated and then fed to the W mode. W mode is a learnable linear layers and learns the residual motion for each frames. We want our new motion word as mode to learn specifically the motion of the protagonist. To identify the motion area, we first collect pre-calculated spatial temporal attention map, which is computed by using each frame as the query and the first frame as the key. This means that the attention scores represent the similarity between each pixel in the first frame and those in the other frames. Therefore, when you find the highest attention scores between these two frames, they tend to be the same semantic points. We track down these similar points across frames and estimate the temporal flow in the video. We extracted motion-related areas by retaining locations where the flow is longer than the predefined hyperparameters. Then we like this, and then we added the regularization term to encourage the cross-attention map of S mode to similar to these areas. We also resolve the problems that the motion and the protagonist get easily entangled. We newly defined a pseudo word as pro that represent the appearance and texture features of the protagonist. Before inflating T2I models, we first optimize the text embeddings of S-Pro. Then, using the inflated T2V model, we train the parameters that generate S-mode. As the protagonist's appearance is already registered In the text encoder, S mode can be effectively learned. Experimental research showed that the superiority of our method, which renders more precise motion than the baselines, especially our spatially captured mouth movement in the source video. Also, our method demonstrates better text alignment, successfully generating a new protagonist, Tiger. This is our project page and paper link. If you are interested in our work, please visit our poster during the morning session on the second day of the conference. Thank you for listening.